Hello, welcome to our last video tutorials, and that is computer networks and communication. We're going to consider the internet and the World Wide Web. So let's quickly take up. Communications and computer networks. First of all, let's define what communication is. Computer communication is the process in which two or more computers or devices transfer data, instructions, and information. I think we use daily. Even as I'm speaking to you now, you're downloading from either YouTube or from the VVU model, and that means you are on a particular network. And that is something that has come to live with us. And each day, with your modern gadgets, computers, mobile phones, and other devices, you connect to networks every day. Now, first of all, for us to have a successful communication, you need a sending device, you need a receiving device, and communication devices. These communication devices, we have what we call the communication channel. Now let's look at this. When we say sending device, it could be your mobile phone. The devices that receive and send are almost the same. I could send a message to you in the form of WhatsApp, a video, whatever it is, and your device can also download it. We have communication device. That's the device that enables one to receive or send the data. And then the channel is the medium through which the message or whatever you're sending is sent. In most cases, communication devices connect the channel to either the sending device or the receiving device. So that's why we have communication devices appearing twice here, meaning we have one connecting the sender, the one connecting the receiver. So the channel really connects the both devices. Now let's see uses of computer. We have text messaging, we have video messaging, we have wireless communication, various forms, and so on. Picture messaging like we have and of late we have video messaging. Okay, so all these use computer network. So let's come back and then define what computer network is. When we talk of a computer network, it's a collection of computers and devices connected through communication devices and transmission media. That's collection of computers and devices connected through communication devices and transmission media. We shall explain all of them one after the other. Now, first of all, we have various types of networks. The most common ones are what we call the local area network. Normally, what we have in Valley View and other small campuses are local area networks. That is, it is managed by a single device. They are within a small geographical area, and one person manages such a network. Okay, so that's why we say that it's a network limited in geographical area, and it could be in an office building, a home, or whatever it is. When the network spans across a whole city, then it becomes a metropolitan area, and that connects several local area networks. Example is a large campus network like that of KNUST, University of Ghana, Legon. Their campuses resemble that of metropolitan area networks because several local area networks add up to form these metropolitan area networks. Now, we also have wide area networks. Wide area networks normally covers very large geographical area, and it could be a whole country, a whole city, or even a whole continent. They form wide area networks, and they consist of several local area networks and metropolitan area network coming together to form what we call the large area networks. Large area networks employ different technologies, different protocols, but they all work together to achieve a common purpose. The internet is the largest wide area network that we have that connects across the entire globe. So let's look at what we call network topologies. A topology is simply the arrangement of the devices on a network, the arrangement of the computers and other devices on the network. The most common ones that we know are the mesh, that is when each computer connects to the other, the star, you have a central point, the bus, and the ring. One that didn't appear here, we call it the hybrid. That is when you connect, you combine any of these two or more, they form what we call a hybrid. We also have, so a hybrid, a tree topology is an example of a hybrid network. Let's look at them one after the other. So this is a mesh. We have one station connecting to each other, and each of them, this is full mesh, where each device connects to the other. You can have a partial mesh in which they connect to each other, but not every machine connects to the other, like we see here. That becomes a partial mesh. Let's remind ourselves, a mesh technology can be implemented in a wide area network style, but not in an office, because a computer, normal computer like my laptop and yours, can connect only one area, one network to it. That means you cannot connect it to several networks at the same time. So take note of that. We have the bus. The bus technology has a central cable or central point that connects all the machines together. So when the cable breaks, the network goes down. And that is one disadvantage of this particular network. Currently, we don't have this network. They are not much in the system, okay, because of the devices we are, manufacturers are coming out now. We also have what we call the star topology, and it is the most common network that is deployed in offices. It consists of a central hub or a switch, and all other devices connect to this hub. So most of the offices, you will see the switch, and all computers or printers and other devices connect to these switches. And that is, they become the central point. One disadvantage of this point is that when the central point breaks down, then the whole network is down. So that is one disadvantage of the star network. It is deployed like a star. Okay, that's why. Then we have the ring topology. The ring topology, it is still in use, and it is one of the fastest networks that is deployed in the world. A typical example is the FDDI. That's a fiber distributed data interface. It's a fiber optic network deployed across the United States, and it is one of the fastest, like I said. It is the backbone that forms the ring consists of only fiber optic. They use what we call token ring technology to work. I will not go deeper into that since you are not a typical IT student. So let's move on. There's a typical hybrid. It has a central hub or a switch, but connects several buses. Okay, so you have about 3 bus networks all joined together in the form of a ring, in the form of a star. This is a hybrid when you combine a star and a ring, a star and a bus technology together. You can have several of them, a bus, star, and so on and so forth. Okay, so let's move on. We have other types of network. We have what we call client server. A client server technology in which some of the machines serve as a client and they request services from a bigger machine called service. These servers provide services. Okay, a typical example is DHCP server. DHCP means Dynamic Host Configuration Protocol, and the server that hosts this protocol normally provide addresses to machines connected to the server. All right. So a server is a special machine that provides services to other computers or clients in the network. So one or more computers act as a server and the other computers as clients, and they access the server. So a printer, okay, machine can access services from the printer by printing, but they pass it through the server. Now, we have what we call peer-to-peer network. Peer-to-peer network consists of, it's like peers. When we say peers, your classmates are your peers in that you have the same qualification, the same pedigree, and none of you is superior. Therefore, when machines are connected as peer-to-peer, each of the machines serve as a client and at the same time a server. Each of them provide a service and it can request service from another. Peer-to-peer networks normally contain files in which all machines that are connected to it can download. A typical example is when you use what service do I even remember? Where you download movies a lot. Okay, you share files and a whole lot. You have the uTorrent. The uTorrent is an example of a peer-to-peer network where the torrent allows every machine connected to download files and other things. Okay, good. So that is peer-to-peer network. Another one, okay, so peer-to-peer is also known as P2P. Okay, they are sometimes called file sharing. Most of the times, it's a disadvantage because they use it to steal movies and other things that are normally supposed to be proprietary. Okay, so let's move on to what we call a bus network. We've already talked about bus network. So all computers are connected to a central cable. Okay, so let's look at how it looks like. So we have a backbone, normally consists of a fiber optic, and all other machines are connected to the backbone. That is a bus network. Well, what we call intranet. What is an intranet? We're saying that an internal network that uses internet technology. Intranet means within. So our organization that deploys a local area network not connected to the internet. Within that organization, we call the network there is called an intranet. But they use internet technology to actually share files, communicate to each other. Okay, so they make information accessible to employees, and they typically include connection to the internet. Good. So extranet allow customers or suppliers to access part of the company's internet. So for instance, you have an organization. You provide services like e-commerce, but you provide sites in which other companies can also log in to request. Let's say, I want these goods, I want that, and then you supply. Such system is extranet. The extranet allows external connection to your network, okay? But within your locality or the company, the network there is called intranet. So let's take note of these two. Now, we have what we call communication that is normally performed over telephone. We have all used telephones before. We call it public switch telephone networks. Okay, these allow voice communication, okay, through a telephone cables. They are normally cables that are connected to each other. Okay, so that's where worldwide telephone systems that handle voice-oriented telephone calls. Okay, so that is what we call the PSTN, public switch telephone networks. A typical example is the network you see in this picture. Now we have what we call the dial-up. The dial-up, they are temporary connection using telephone line for communication, cost no more than regular call. Dial-up is almost like a regular call. Computers at any two locations can establish a connection using a modem and telephone network. That is very common. So two machines can communicate through something we call like a telephone line and communicate to each other. We call it a dial-up communication. Now we call it, we have also dedicated line. A dedicated network is normally where you subscribe and you the line is assumed to be yours, okay, dedicated to you alone, okay. So we have what we call the integrated service digital network lines, DSL, and so on and so forth. I would like you to read more on this particular one. Always on connection between two communication devices. We have the dial-up, the ISDN, DSL, cable TV, like the ones we normally subscribe in the homes. Then we have fixed wireless lines, fractional T1, T1, T3, and then ATMs. The ATM here is not an automatic teller machine. We have what we call the asynchronous transfer mode. That is ATM, normally used to deliver high definition TVs to our homes. Example is the DSTV. Okay, so take note of that. All right, so examples of communication devices. Let's look at some of them. Common types are what I just mentioned. The dial-up modems, the ISDN, the DSL. ISDN means Integrated Services Digital Network. Digital subscriber lines, modems, cable modems, wireless modems, network cards. They are the small cards used in computers to access a network. Wireless access point, normally wireless, routers and hubs. All are communication devices used in the offices. Please read into detail what all these devices are used for. Okay, so a dial-up modem, like I've just explained, okay, converts digital signal and analog signal and vice versa, usually in the form of an adapter card. So when we say a dial-up modem is a type of modem, you know, the modern world is digital. Most of the old machines are analog. Or most of the signals in nature are analog, like my speech. But it has to be converted to digital. So dial-up modems convert both from analog to digital and then digital to analog for the machines to really interpret. Okay, the ISDN and the DSL modems. Okay, they are communication devices that send and receive digital signals. Let me put it that way. And they're usually external devices in which one end connect to a telephone line and the other end connect to a port on the system unit. So it's like a cable in which you slot the RJ45. We have the RJ11. You slot it in and then you connect to the device, normally fixed at the end of your end. We find these things also in internet cafes and so on. So we have the cable modem, sends and receives data over cable television network, and it is much faster than the dial-up modem or the ISDN. It is sometimes called what you call the broadband modem. Okay, the broadband modem. We also call it the cable modem. Now, let's quickly move on to wireless modem. A typical example, I have a wireless modem here, which I'm using. The small modems you connect to your machines. The internet cafes also connects modems so that you can browse their network. So they are normally connected to laptops, notebooks, ordinary towers, PDAs, and even what? Phones of late. So let's take note of that. We have the network card. The network card is what connects a computer to a network. Without it, you cannot. So normally when you look at the back of a computer, you see where you slot in the network cable. Okay? Right. That is what you see on the screen. That's here. That's what you see on the screen. So you slot it here. The card is inside. Okay? And that is what converts all the videos and other things you are sending and place them on the wire and then send them to the destination in which you go. So we call them network interface card. Okay? So that is it. And we have the wireless access point. These are what you call the wireless routers that enables wireless devices to connect to a network. Okay, so sometimes you come to a campus, you have various access points in which you can sit and then connect your laptops or phones to the network and then you start browsing. So these wireless points in which you can, when you go, you are out of the radius, you can't access the network. You see that it's not there. So that means they have a range in which you can access these networks. Call them wireless access points. Now, what is a router? A router is a device that connects one computer or one network to the other. They link two networks. And they can link one network to the internet. Okay? So for instance, if you are in Valley View or any other particular location and you are accessing the internet, it is the router that is connecting your local area network onto the external internet. So they forward data on the internet using the fastest path available. They have built-in hardware firewalls, and in fact, we have a category of routers, and each of them can perform different functions depending on the capabilities. The higher the capability, the higher the price. And therefore, they go that hand in hand. All right, a hub is a device that normally connects several computers together in a network. We have what we call the active hub and then the passive hub. Okay, good. Hubs are not as fast as a switch because they have one collision domain, meaning only one device can transmit data at the same time. So normally, currently, all local area networks are using switches instead of hubs. In other words, for a switch, all the machines, we have the 8-port switch, the 16-port, the 24-port, and even 48 and even 96 ports. All the machines can transmit data at the same time if you are using switches, unlike hubs. So, friends, that is how the difference between hubs and networks, or hubs and switches. Now, a home network, that is when you connect that is different machines together in your own home. Okay, we have different types of home network. We have the Ethernet. The Ethernet means you use cable. You build a central point, probably you put a switch there, and you connect small connections to each other, and then using the RJ45, and then you can use cables to connect, just like you see in this picture. So they have the power cable and then the phone lines. They can be used in home networks. So they are normally, home networks are normally private networks used in individual homes or offices. So let's talk about communication channel. A channel is simply a path through which data is transferred from one machine to another. So channels are normally transmission media. When we say transmission media, we are talking about a medium in which the communication passes or data passes from one machine to another. For instance, if you connect cables, then your media becomes a cable. If you use wireless, then your media becomes what? A wireless. These are the two main media. Currently, we also have the optical fiber, which converts or what? In which data travels in the form of a light. So we have cable, normally it's part of a cable, but we have the optical fiber cable, normal metal cable, that's copper cable, and then we have what we call that is a free air wireless transmission. Okay. So how is data transmitted through communication channels? Okay, if you look at the diagram carefully, you're looking at the physical transmission media, wire or cables and other tangible materials used to send data. That's what we call the transmission. So here, like I said, we have cables that are normally consist of copper wires and cables that are consist of fiber optics, a glass. So light, the signal is converted to light and transferred through. And the last one is either through air converted in a form of electromagnetic waves. Okay, so these are the physical media. So the cables consist of twisted pair. I hope all of you have seen a network cable before. Okay, you open it, you see several wires twisted to each other. Have you seen that? Okay. And then we have the coaxial cable. Normally comes like the one we use to connect a television. Coaxial consists of a single wire, copper wire in the middle, and then braided whitish silver that is around it. Okay, right. And then we have the fiber optic, like I just mentioned, consists of a glass fiber. Okay, and that's the best. Very high speed and less noise. Okay, this is how we have the multi-mode and the single mode. Good. So that is how it looks like. So wireless transmission media, I just mentioned, when you cannot easily convert what lay cables and so on, wireless become easy. Okay, and several devices can access it from any location. So wireless is good. We have several types of these wireless. Currently, you have short range ones like the Bluetooth and the infrared on your phones, and you can use it to transfer data from one phone to another directly without passing it through any network. We have the home RF. Okay, right. Each of them has a different speed, but it also have the range, the range by which data can be transmitted. Some of them, they require the devices to be at the vicinity of each other. We have the microwave radio, okay, and a communication satellite. That is, we shall discuss it further, so let's go ahead. So, what are broadcast radio and cellular radio? The broadcast radio distribute radio signals over long and short distances. The cellular radio is a form of broadcast radio used for mobile communication. So when you're talking, hello, how are you? You're talking through cellular radio in a form of broadcast radio in which the signals are, that's what the telcos provide. So they are in cells. When you move, you are in motion, you transfer from one cell to another, okay, so that your communication can be continuous. They are allowed by a radio what? Communication spread across the entire cities or countries for you to do that. So you have access points by these telcos, that of MTN, that of Vodafone, that is when you talk about Ghana. So that is one mode. Then we have the microwave station. These microwave stations are Earth-based reflective dishes used for microwave communication. That's what you refer to as satellite, but they are not satellite. So you see the towers there with a pan-like, a dish, okay, that is either concave in nature, and they transmit data from one device to another. Have you seen within this diagram? Have you seen these pictures before? They beam large amount of data and from one of such devices to another, and they receive and retransmit to other areas. So let's look at communication satellite. A satellite is a space, look at this. It's a device that orbits the Earth at a certain height, okay? And they have an Earth station in which data is transmitted to the space station, and it is broadcast to all other parts of the globe, okay? And these signals travel in the form of a microwave, which is also radio, okay? Microwave means short range radio waves, okay? So these satellites orbit on the Earth, and by that they transfer signals from one part of the Earth to another. All right. So What are ways to access the internet? We are what we call the ISPs, that is Internet Service Providers. These Internet Service Providers are regional, they can be national, okay, and so on and so forth. They also depend on other Internet Service Providers to provide services to us. So Ghana, for instance, we have MTN, we have Vodafone, they are all Internet Service Providers. When you require internet to your location, they are the people you go. They will install their devices, log in, and you're there. They also receive services from other companies that own these satellites and other global communication devices. So that is it. We have the R and the MNS and so on and so forth. Good. So let's go ahead. How might data travel on the internet using cable modem and so on and so forth? These ones are a bit above your class, so I wouldn't want to bore you with it. So let's move on quickly. Right. Normally, when you are browsing the internet, all that you talk of is what? Oh, I want to go to Google. I want to go to Yahoo. I want to go to Facebook. The internet doesn't know Facebook. All that they use to communicate is addresses. It's like a city. If you want to locate somebody's house, what do you use? Address. So the internet also, every device connected to the internet has an address. And we call that Internet Protocol address. That is IP address. It consists of 4 octets, and each octet ranges from 0 to 255. For instance, we have 216.239.39.99. Each of these octets should not exceed 255. The maximum will be 255. Okay, there is a reason for that. We have what we call the domain name. Domain name is the name that is assigned. The internet uses the address to locate the domain names. And we have what we call the domain name server. This server converts your domain name to the address that you. So when you go to your browser and then you type google.com, the IP, the domain name is converted to the IP address of Google by what we call the domain name server. Okay, so the domain name server converts the name to an internet address that can be located. So Google is not known. There's an address for Google, but because we cannot put the address in our heads as humans, we rather use the names so that we configure a device on the internet that will convert the name to an IP address. So we have several domain names. Normally, when you have the domain names end with dot something, for instance, .com is a commercial organization. Valley View is vvu.edu. What? EDU means education. GOV is government. Those of you who have been applying for the US visa, see that www.lottery.gov. That is US government. We have the military organization ending with what? .mil, .net, .org, and so on and so forth. These are top level domains that we use. I hope we understand this. Now, let's look at the World Wide Web. The World Wide Web is a collection of electronic documents and is also called the web. Each electronic document is called a web page. So normally, when you browse the internet, you're browsing documents, pages containing several data. So when you type, you search through, let's say using a Google search, it goes through several pages on the internet looking for whatever you wish to find. And these pages combine to form what we call the World Wide Web. The internet is an interconnection of networks and computers. Okay? But the pages, the sites that provide these documents are the World Wide Web. So it can contain text, graphics, sound, video, and built-in connections called links. A website is a collection of what? A related web pages. So when you go to Valley View website, all the pages there are related to Valley View. Okay, so that's why we call it Valley View website. So you go to Facebook, everything you find at the top are made up of what? Facebook documents. Okay, so that is it. So the World Wide Web, what we use to access the web on your computer is called a web browser. So example of a web browser, what example do you have on your phones? You have browsers there. Have you seen the Opera, the Firefox? Okay, currently I use what? The Internet Explorer, and so on and so forth, the Netscape, and so on. All these are called browsers. They are applications that enables one to access the World Wide Web or any information you want to access on the internet. The first page in which you log in on a particular website is called the home page. And this home page normally contains tabs and other things that enables you to navigate through that particular site. Okay, they provide links to other pages of that particular site. So that is a home page. Now, how do you handle computers and cellular telephone access? Access the web. So we use what we call micro browser and displays web pages that contain mostly text and images. Must be internet enabled. So we use cellular phones to access. The browsers on your phones are normally mini, designed to work with your mobile phone. Okay, the machines like computers and other things have the full browsers. What is downloading? That's the process of fetching data from the internet onto your computer. It's called downloading. When you are fetching transferring from your computer to the internet, it is called uploading. So friends, now let's look at this. What is URL? That is a Uniform Resource Locator. That is a unique address given to a particular website on the internet. When you use www.vvu.edu.gh, that is the URL of Valley View. So facebook.com is a URL of Facebook. Okay, that's a unique address of that particular site. A search engine is an application or a program normally found on a website that is used or enable the user to search for a particular document or a site. Okay, we have several search tools that are used. So give me an example. Google is an example of a search engine. Yahoo, what do you remember again? Several of them. You type a particular phrase, okay, and the search engine takes your phrase, compares it to the nearest it can find on the internet, and pops all of them up for you to search for what you're looking for. So friends, I want you to read more. This has been a very short lesson though, but there is so much to it. So take the lessons one by one, find more information, read more about the internet and the World Wide Web. And I believe that has been a good opener for us to actually work on. God bless you and stay put. God willing, you're going to have a quiz in a short while. So go through this lesson as fast as you can. God bless you. I was going to spend even an hour. Come on,